Being recorded. Hey everyone, welcome to another Open Cluster Management Community Meetings. Today is 2023, April the 14th. Today on the agenda, we have Add-on Template by Zhu Zhang. So really exciting topic. Zhu Zhang, without any further delay, please take it away. Thank you.
Okay, thank you. Hello, everyone. Let me share my screen first. So can you see my screen?
Yes, we can.
Okay, today my topic is about a new enhancement. It's called Add-on Template. Currently, if we want to develop an OCM add-on, we can use the add-on framework, and we can use add-on framework to implement some interfaces defined in the add-on framework to describe what resources need to be deployed on the main cluster and how the add-on agent will register to the hub cluster. But all of this will need to implement by coding. So in this proposal, we want to simplify the development process. So the developer to implement the add-on just by configuring some YAMLs, not by coding. Yeah. So, and this is also the first goal of the proposal. If a developer want to develop an add-on, you just need to define an add-on YAML template and some parameters to describe how the add-on agent will be installed on the main cluster and how to register it to the hub. The first goal. And the second goal is if there are some changes on the agent deployment or the registration logic, we don't need to recompare the add-on image again. Yeah. And there are two non-goals for this enhancement. The first is with this proposal, we don't need the add-on manager again. You know, we with the add-on framework development process, I mean the old one, every add-on needs one add-on manager deployed on the hub cluster, and the add-on manager will deploy the agents on every main cluster. But with this enhancement, there is no need for deploying add-on manager for every add-on. But the add-on agent image is still required. Yeah. And second, for complicated add-ons, for example, the add-on has special RBAC requirement that would still need to use add-on framework. Yeah. So next, let's look at the proposal design. First, about the user story and the story one. As an add-on developer, I hope they can focus on my add-on business development. After prepare the add-on agent image, I only need to define some YAMLs to deploy and register my add-on. No need to implement some interface by coding. And the second story is as an add-on developer, when the installation and registration of the add-on agent changes, I don't want to recompare the add-on image again, but just by configuring some YAMLs. Yeah. So the main idea to achieve this is we will provide a new API add-on template, and which is used to describe how to deploy add-on agent and how to register to the hub. So there are two main parts for the add-on template. The first is agent manifest field. In this field, we can define what resources, what Kubernetes resources of the add-on agent to be deployed on the main cluster from. For example, we want to deploy an add-on agent deployment and a service count, a role, and a role binding. So we can read 4 YAMLs for each one by this field. It's a slice and it's required. It will define what resource will be deployed on the main cluster. Yeah, and if the add-on agent want to access the hub cluster, we also need to define the registration part. So when we talk about the registration, there are two parts of work. First is there should be a way to provide a certificate for the add-on agent to access the hub cluster. It's about the authentication part. And the next part is there should be a way to define what resources on the hub cluster that the add-on agent can access. I mean, the authorization part. Yeah, so we provide this field to define something like this. So there are two tabs of registration. First is the Kubernetes client tab. In this tab, the add-on agent can access the hub Kubernetes API server. And so when there is a registration config for the add-on template, when the add-on agent running on the main cluster, it will create a CSR on the hub, and the CSR sender name will be this. So the hub cluster's built-in sender will find this CSR and issue a certificate for the agent. Yeah, it's authentication for the Kubernetes client tab registration, but we also want to define what resources that the agent can access on the hub. We can define by this field, the Kubernetes client registration config. So it contains a permissions field, and in this field, there are also two tabs. For the first tab is a current cluster. So if it's a current cluster, that means the add-on agent can only access resources in the main cluster namespace on the hub cluster. For example, the main cluster 1, there will be a cluster 1 namespace on the hub. So the add-on agent can only access the cluster 1 namespace resources. Yeah, and we will also need to reference a role on the hub cluster. So in the role, users can define what resource can be accessed, and we will create a role binding in the main cluster namespace on the hub, so the agent can access these resources defined in the role. And this role should be created created by the users, not for the add-on manager. So it should be created before the add-on before the add-on agent running. And there is another tab, the single namespace. So in the current cluster, the agent can only access the manual cluster namespace. But if the agent want to access a resource in another namespace, we can use the single namespace to define which namespace that the agent can access. So in this field, we can define the namespace name. So the current cluster tab is the special case of the single namespace tab, but this will be the default tab. Okay, so this is about the Kubernetes client registration, and another tab is a customer signer. So if an add-on agent want to access the hub cluster through user-defined endpoints, not the Kubernetes server, we need to define the registration via the customer signer way. So in this tab, the built-in ABS server signer will not sign the CSR. So the developer need to define how the CSR will be signed at this field. So it contains a signer name. Developer can define the signer name, and we need a signing CA. It's a secret reference. So the add-on manager will use this secret to send the CSR to issue a certificate for the add-on agent. But for the customer signer type, the authorization part will not taken care of by the AddOn template controller. So users need to implement the authorization part by themselves. Yeah, that's almost for the AddOn template API. And so next I will give more explanations. So for the first part, it's about the template rendering. So in the agent manifest, we can define some resources. What resources need to be deployed on the manual cluster. And we can also use some built-in variables for the template. And we provide now we provide 5 built-in parameters. Some of constant, they cannot be override by users variables. For example, the class name means the add-on agent is deployed on which manual cluster. For example, the cluster 1, and the install namespace where the agent is installed on the manual cluster. And the install mode, it could be default or hosted. And we also provide 2 default parameters, and this can be override by user's variable. First is a hub Kubernetes config. And so in this path, the add-on agent code can use this to path to get the hub Kubernetes config. Another one is the manual kube config. It's only used in the hosting mode. And so we will inject all of these built-in parameters to every containers by environment. So with this, the agent image code can use these parameters by getting the environment. Yeah, and if the AddOn template has some registration defined, that means we need to access the hub, so we'll inject some volumes. First, we'll inject the hub kube config volume. It's just like this. In the volumes, it's a secret type volume, and we'll create this secret on the main cluster, and we'll bind this volume to every containers of the AddOn agent, so we can use this hub kube config to access the hub. And if it's a hosting mode, the AddOn will also bind the main cluster kube config. It's similar to this one. So I will skip. And users can also use variables in the template in the format of like this. It's similar to a Go template syntax, but not the identical. And for now, we only support string values. So there will be two types of variables. First is the built-in variable, and all parameters mentioned here, I mean, this 5 will be mentioned here, will be provided for the user to use in the template. And another type is customized variables. User can define their own variables by AddOn deployment config. Yeah, and I think that's let's look at a demo to make this more easier. First, here's an AddOn template example. So in this example, we defined what resources will be deployed on the agent via this field agent manifest, and we can see there's a deployment, and there's a source count, cluster binding, and in the deployment we can use the built-in variables install namespace to describe this agent, where this agent will be installed, and we can use a customize the variable, the log level, and users can define the log level value by AddOn deployment config. Let's take a look. AddOn deployment config here. We define log level 4. And we also need to reference this AddOn template in the cluster manager add-on. Here, the supported config, we reference AddOn template, hardware template here. So if a cluster management add-on has this AddOn template temp resources supported in their config, that means this is a template tab add-on. Yes. And we also mentioned that for the Kube client registration, the user need to create the class rule or the rule by themselves. So in this example, there's a class rule and a rule we will create it. And for the customized registration, user need to provide a signer the secret. It's here. Next slide, I think I can give a demo in my environment. First, we will run an AddOn Template Manager. It's running now. And the left window is the hub cluster, and right is the main cluster. And the main cluster name is cluster 1. We'll deploy a hello template add-on. Now it's not deployed the cluster 1. And let's apply this example YAMLs to the hub cluster. After this is created, so there's a main cluster add-on hello template, but it's not available. And we can check the add-on template. It just look like this. And we can check web resources. Sorry. I cannot connect. Wait. It's in the container creating status. Let me check this. If current is issue. Yeah. Oh, now we can see the hello template agent now is running. And the add-on status should be available. This change. Oh, now it's available. So I will compare the add-on template with the pod here. You can see in the template we define the class name like this, and now it's class 1, and the add-on namespace is open class management agent add-on, and log level we defined it in the add-on deployment config is 4, and we inject this built-in parameters to the environment, and we mount the hub kube config. Yes, that's it for demo. Let me back to the proposal.
Can I ask a question, a quick question?
Yeah,
Sorry.
sure. Okay.
So in the oh, could you go back to the terminal, please? In the terminal, you were showing the template and what was on the pod. And on the template and on the pod as well, there's the image, like the Quay.io, Zhujiang add-on examples.
Yeah.
I know there's no magic. I still need to create that add-on example and push it to Quay, right? Or some image repo, right?
Yes. The add-on agent image is still required.
Got it. Thank you.
Yeah, and we'll talk something about this later. And yeah, that's what I want to say now. So for now, how to probe the healthy of the add-ons. Now there's a requirement for the add-on agent. You need to periodically refresh these resources, and the list is it has the same name as the add-on and is located in the same cluster and namespace where the add-on agent is deployed. So for our example, it's here. Yeah. So this add-on agent need to check the agent if it's healthy, and if it is healthy, you need to refresh this list. So the so from the hub side we know the agent is healthy. It's a requirement for the agent. So we need to implement this updater interface to achieve this. But in order to get rid of this requirement, we are considering another type of healthiness probe. I mean, we can inject a feedback rule to check if the agent deployment resource is available. I mean, we can check the add-on agent deployment status, the available status, if it is true. So with this, the add-on agent image will not need to implement the list updater interface. But we are still considering this. And yeah. So Mike, did you resolve your question?
Yeah, that helped my question. I was hoping, I guess I was a little bit dreaming, but I was hoping I don't need to make the image at all. But I guess I was yeah.
But
Do
if
you think
without
that's
the
I know you mentioned that with the feedback
yeah,
maybe we can replace the leads, but I for example, I just for the most basic add-on, I just want some manifests being applied and then check the health of those manifests. Do I really need to make my own image for that?
the agent image is still required because the add-on business logic is in the agent image, right? So
Okay.
I think it's still required. But what we can do is we can make the developer no need to implement this update interface anymore. So they just need to apply. They just need to provide any agent image to achieve their business goal. Yeah.
Just to clarify, it doesn't need to. So maybe we should not call it agent image because it actually just like any runtime image is fine. It doesn't need to be a specific OCM agent. It could be, for example, it could be a Argo CD, for example, Argo CD deployment, or it could be some other any deployment that you want to deploy using the add-on fashion. That means that you can define which cluster you want to install this to. Yeah, and you can define like using the install strategy to define under which clusters, what's the config for these certain tools.
So
Yes.
in the most basic example I can think of, it's I have a bunch of manifests, say an Argo workflow. I wanted to those bundle of manifests deploy into all the managed clusters. So how can I so in the example it shows like the image, like the so the, I, you call it the agent image, but that's just one field of defining the deployment, right? How do I have that whole sets of manifests being applied without writing code? Because I'm trying to avoid writing like additional OCM specific code.
I think the thing using this template is that just put the manifest of Argo workflow deployment into the add-on template, and then you can build a add-on called Argo workflow add-on. So then create the add-on template on the hub side. And when the user want to enable the Argo add-on, Argo workflow on a certain cluster, you just need to create MC manage class add-on on this cluster. So that's a way that you can use. So there's no need to write any agent code. There's no way to write any code specific to ACM. The only thing that you need to do is to put the deployment manifest of the Argo workflow into the template.
I see. Thank you.
Yeah.
But then
Oh.
it might get really big, no? Like if there's I guess it's the same. I guess it's the same issue even if we do it the traditional way. Or
Yes. Yeah.
because in the traditional way, I think there there's some files that you can put in, and I don't have to specify it in the CR. So I wonder if we can do something like that here as well, or that's not possible.
I mean, put the CRs in where? In the agent or in an image or in?
I'll come back after I find the example. Sorry.
Okay, no problem.
Okay. So I will continue for the last part. So think back to the user story tool. We want to upgrade an add-on. So how do we do the upgrade for upgrade add-on with add-on template way? This we will leverage the add-on lifecycle management feature and the install strategy feature to achieve the first. Here's an example. First, we will create a new add-on template to contain the change. For example, here we add a new label add-on template version 2 for the add-on. Yeah, and the new add-on template named hello template v2. And next we need to create a placement to select on which clusters we want to do the upgrading. So in this example, we create a placement to select all clusters. And third, we will we need to change the add-on template reference in the cluster management add-on. So here in the install strategy field, we reference the placement that we created to select all clusters, and we change the add-on template to the new version v2. And after this, this new template will be upgraded. So we don't need to recompare an image just by this configuring YAMLs. Wait, yeah. I think that's all for the proposal. Any other comments?
I think this is an excellent proposal. I mean, this is something the community has been asking for for a while now. And I myself went in a few add-ons and it was quite difficult as well. So with this definitely make it a lot easier. So
Yeah, thank you. So if there are the PR of this proposal is submitted in the enhancement repo. So if you have any comments, it's comments are welcome for this PR here. Okay, I think that's all for me. Thank you. I will stop sharing.
so Qzhang, maybe we can talk in the meeting. So I just want those manifests to be applied to the managed cluster, maybe not in the form of the agents. So if I don't write any code, do I create a add-on template and list out all the manifests?
Sorry, I still don't quite understand. You mean?
Yeah, I think that's a questions on the chat. I think the answer is yes to me. If this all this manifest need to be deployed on the managed cluster, we need to put those manifests into the template. So I was thinking that yeah, I was thinking that better way in the future, if we have this API, is that we could have a class ADM command line, maybe just to build the add-on template. And then you can basically use customize or Helm chart, Helm to render the manifest at the first step, and then the build command can put this manifest into a template API.
Got it. Thank you.
Yeah, so in that way, it means that you don't need to touch anything. Just for example, if there is manifest on GitHub, you can use customize to fetch it, render it, and then build the add-on in one command. But yeah, it's my imagination.
So on the agent side, in terms of customizing the agent, so there we talk about the health probe as one of the option. Are there any other maybe I skipped it because I was looking through my example. Any other customization we can do for the agent, or it's just mostly the health probe?
The health probe currently, we think that we actually at the first step, we probably only check whether in this template manifests is there any deployment, and if there is deployment, we check the available conditions of the deployment. If all the one is available and we think the add-on is available, in the future we might be able to customize some part, like we can define some kind of rules on the template API to just say under this rule the add-on is available. But yeah, it's still not clear how to do that to me yet.
No, thank you. I think this is really great. I would love to play with this, and hopefully, we have now an easier framework for people to publish their add-on if they're interested in the add-on deployment. Because I use the add-on framework and I try to make a few add-on. It was quite difficult.
Yeah. I think that will ease a lot of work for like add-on that is quite easy. For example, maybe we just need to deploy Argo workflow or Flux onto the managed cluster using add-on, and that could also template way could make it much easier than before.
Yes, absolutely. Thank you. Thank you, Zhu Jiang and Qiu Jiang.
Thank you.
Okay, thank you.
Are there any other comments and questions? If not, thank you everyone for joining. Have a nice day. Take care. Bye.
Right.
Bye.